In this lesson, we're going to discuss how to write a balanced chemical equation if you're given a word equation to start with. Now, this is going to put all the skills that we've learned together in chemistry in one question. We're going to have to identify what type of reaction something is and maybe use that pattern to complete and predict the products. We're going to be changing chemical names into formulas, and we're also going to be balancing equations. So let's do a quick warm-up. For these three chemicals, give me their proper chemical names, and for these three chemicals, change these names into formulas. Pause the video here until you have your answers. Here are the answers. For the first one, Na2O, that's an ionic compound because I have a metal and a nonmetal. So following the ionic rules, I write down the name of the metal, sodium. I write down the name of the nonmetal and change the last three letters to IDE. So oxygen becomes oxide. For question number 2, this is a molecular compound. I have two nonmetals, nitrogen and oxygen. So I need to use prefixes in my name. I write down the name of the nitrogen, and because I only have one of them, I can stick a mono out in front of it. That mono is optional if you want, because it is on the first element. But for my oxygen, I change the last three letters to IDE, it becomes oxide. And because I have two of them, I need to stick a di out in front of it. For the third question, I have AlF3. This is ionic because aluminum is a metal and fluorine is a nonmetal. So I name the metal, aluminum. I name the nonmetal, fluorine, but then change the last three letters to IDE, so fluoride. For the formulas, again, you need to make sure that you figure out, is your compound ionic or molecular? For magnesium phosphide, because magnesium is a metal, I need to use the crisscross method. I look up the elements on the periodic table and find their charges. Magnesium has a 2+, phosphorus has a 3-, and then I crisscross them. I take this 2, put it down here, take that 3, put it over there. I end up with Mg3P2, which is in lowest terms. For calcium oxide, calcium is also a metal, so I need to use the crisscross method. Calcium's got a 2+, oxide's got a 2-. If I crisscross that, I'd end up with Ca2O2, but my last step is to reduce it into lowest terms. It's going to be CaO. For question 3, I see some prefixes in my name. That means it's a molecular compound. Also, you can notice that carbon and hydrogen are both nonmetals. These prefixes tell me what subscript numbers I need to write down. The symbol for carbon is a C. The di means I have two of them. The symbol for hydrogen is an H. The hexa means I have 6 of them. You don't crisscross these numbers. You only crisscross ionic compounds, and you only reduce ionic compounds as well. Now that we've reviewed those names and formula skills, let's start stacking other skills on top. Our mission today is to take a word equation, which is a reaction described by using the names of the chemicals, and change that into a balanced chemical equation with the element symbols. We're going to do this in 3 steps. Step number 1, we're going to change each chemical name into its formula using the proper rules. So if it's an ionic compound, we crisscross the charges. If it's a molecular compound, we use the prefixes to get our subscript numbers. If we need to, we can predict the products and complete the equation by looking at what type of reaction it is and following the pattern. We don't always have to do this. It depends on what they give us in the question. Step number 2. If we have element names in our reaction that are not in a compound, so they are by themselves, they don't get any little subscript numbers, except if it's hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine. These elements are what are called diatomic. When they are by themselves in their pure elemental form, they actually come in pairs. So step 2 is if you have any of these special elements, put a little 2 beside them. Once we have all our names changed into formulas, then we can balance our chemical equation by adding those coefficients, those big numbers out in front of the chemicals that multiply our atoms so that we can make sure we follow the law of conservation of mass. So here are those diatomic elements again. And one way to remember them is if you take the symbols for the elements that come in pairs and string them together, they spell Hofbrinkel, which kind of sounds like a clown. So some chemists like to remember these ones by thinking of Hofbrinkel the clown. Whenever you have a Hofbrinkel element, that means they exist with 2 identical atoms bonded covalently to each other. For example, if you ever see the name oxygen or oxygen gas, you want to write down an O2, not just an O. Same thing for nitrogen. If you see nitrogen or nitrogen gas in a word equation, the formula for that is an N2 because nitrogen is one of the special Hofbrinkel elements. Another way to figure out if your element is diatomic or not is by looking at the paper copy of your periodic table. What I've done is I have written their symbols actually in white. So if you have a look at our periodic table, you notice that hydrogen, the H is white as opposed to the lithium where the Li is black. That reminds you that when hydrogen is by itself, it's an H2 as its formula. The same goes for nitrogen, oxygen, fluorine, and actually everything in group 17. Chlorine, bromine, and iodine as well. Let's try out our first word equation. Step number 1, change all the names into chemical formulas. So when I see iron, hey, that's an element by itself, I just write down its symbol, Fe. Now iron is not one of our special Hofbrinkel elements, so it doesn't get any little numbers. I copy down my plus sign from my equation, and now I have the name oxygen gas. Well, the symbol for oxygen is an O, but oxygen is one of our special Hofbrinkel elements, so it gets a little 2. That's going to produce, so I copy down my arrow, and I have the product, iron oxide. Well, this is a compound because I have 2 elements, and it's ionic because iron is a metal and oxygen is a nonmetal. So I need to find my charges and crisscross them. Iron on our periodic table is an Fe and it has a 3+ charge on it. The oxygen is an O with a 2-. And then I have to crisscross the charges. So the 2 is going to go down here, and that 3 gets crisscrossed over there. So now I've changed my names into formulas. And once you're done crisscrossing ionic compounds, you do not need these charge numbers anymore. They kind of distract me and they get in the way, so I either erase them or scratch them out before I do my next step. My next step is to check to see, is my equation balanced? On the left side I have 1 iron, but on the right side I have 2. That means I need to put a coefficient of 2 on the left-hand side. For my O's, on the left side I've got 2, but on the right side I've got 3. Remember our strategy, whenever you have 2 on one side and 3 on the other, turn them both into 6. So on the left, I'm going to put a 3, because that gives me 3 times 2, 6 O's on the left. And on the right, I'm going to put a big 2 out in front. That gives me 2 times 3, 6 O's on the right. Remember, when you're balancing, you can't change little subscript numbers, and I can't squeeze in a 2 here. I can only put my coefficients out front of my formulas. But you notice now, that's by putting this 2 here, it's messed up my FEs. I've got 4 FEs on the right, so I'm going to have to change this coefficient. So now I have 4 FEs on the left. Finally, I can identify the type of reaction that occurred. Here I have an element plus another element forming a compound. I have 2 things becoming 1. That's the definition of a synthesis reaction. Let's try out example 2. Step 1, change the names into formulas. My first name is calcium. Hey, that's an element by itself, so I just write down the symbol. No little numbers, no charge numbers or no subscript numbers. Then I copy down my plus sign. I'm given the name hydrogen monochloride. As soon as I spot that prefix, I know that this is a molecular compound. Hydrogen's a nonmetal, so is chlorine. So I do not have to look up the charges and crisscross. I'm going to use the prefixes to get my formula quantity numbers. So there's no prefix in front of the word hydrogen, so that means I just have one of them. And mono in front of the chloride means I just have one chlorine. So my formula is going to be HCl. I then copy down my reaction arrow. In example 2, they don't tell me the names of the products. What I can do though is predict what gets made by looking at what type of reaction it is. Notice here I have a metal by itself and it's attacking a compound. So this calcium can steal the chlorine's partner, and that's the classic single displacement pattern. As products, I'm going to have my calcium going with my chlorine and kicking out the hydrogen all by itself in that bodybuilder stealing a nerd's girlfriend pattern. When my calcium and my chlorine join together in a compound, it's going to be an ionic compound because I have a metal going with a nonmetal. So to get the correct formula, I need to look up their charges and crisscross. Calcium has a 2+, chlorine has a 1- on our periodic table, and then I crisscross the numbers. Looking at this hydrogen, I also have to modify its formula. Hydrogen is one of our Hofbrinkel elements, so it needs a little 2 beside it because it comes in pairs when it's by itself. Now that I have all my formulas correct, I can erase these charge numbers or scratch them out so that they don't distract me as much. Now I have to balance my equation. On the left side, I've got 1 calcium. On the right side, I have 1 calcium. So that's fine. But on the left side, I have 1 hydrogen. On the right side, I have 2 hydrogens. I need to put a big coefficient of 2 in front of the HCl so that I follow the law of conservation of mass. This now gives me 2 chlorines on the left side because I have 2 times 1, and this gives me 2 chlorines on the right side. I'm now balanced. Here's one last example. Magnesium fluoride plus aluminum nitride. Pause the video here and try this one out on your own. Here's the answer. The first step is to change these names into formulas. Magnesium fluoride is an ionic compound because magnesium is a metal. So I have to find the charges on each piece and then crisscross. I'm going to react that with aluminum nitride, which is also an ionic compound because aluminum is a metal. I look up the charges on each piece, I crisscross, and I reduce. This looks like a double displacement pattern. I have 2 elements plus 2 elements, so they're going to swap partners. To predict what gets made, I follow the double displacement pattern. The first goes with the last. So my magnesium is going to go with the nitrogen. And then the third goes with the second. My aluminum is going to go with the fluorine. Now I need to re-crisscross these formulas. Because they're both ionic, they both start with metals, I need to re-look up their charges and crisscross. Now that I have all my formulas, I don't need these little superscript charge numbers. So you can either erase them or cross them out like I'm doing, so that they don't distract you when you go to try and balance. Let's do the magnesiums first. On the left side I've got 1, on the right side I have 3. This gives me 3 times 2, so 6 fluorines. On the right side I only have 3. This gives me 2 aluminums. On the left side I only have 1. This gives me 2 nitrogens and 2 nitrogens. So now I'm balanced. You notice for this question, all of the skills we've done so far in chemistry get stacked together. So the steps are change your names into formulas, figure out what kind of reaction that you have, and predict the products if they don't give them to you in the question by completing the pattern. Then balance your equation by putting big coefficients out front so that you have the same number of atoms on the left side as you do on the right side. Try out the questions on the word equation worksheet. Question number 1 is like example 1 we did in the lesson, where they give you the names of all the chemicals involved in the reaction. Question number 2 is like example 2 and 3 that we did, where they just give you the beginning of the equation and you need to predict what gets made by following the reaction type pattern.